section 5.3 part 4 is kind of putting it all together. So it's the summary of curve sketching. Okay, so we're going to go all the way through these problems. I know, it's a lot. Oh, did you like my, because I'm not letting you get credit for calculus without learning this? Is that what you're giggling at? Yes. Because part of calculus is knowing how to graph everything. Like, it teaches you how to graph anything that you would ever want to graph. Okay, so the guidelines for sketching, girls, is you would find the domain, you find the vertical asymptotes, the first derivative information, second derivative information, horizontal asymptotes if there's any, and the intercepts. So we would go through all of these steps. Now some of these are not going to have asymptotes. Like this first one, no asymptotes. So it says sketch the graph of the following functions. Okay, so my domain is negative infinity to infinity, right? I can plug in whatever I want for x. I'm never going to get undefined. There's no vertical asymptote. My second derivative, or my first derivative is 12x squared plus 36x plus 24. Okay, when I do that first derivative, I always set it equal to 0. I want to find where it's increasing, where f of x is increasing, decreasing, and so on. So I'm going to have 0 equals, I can pull out a 12. I have x squared plus 3x plus 2. So it factors into x plus 2 and x plus 1. All right, so I'm going to have critical values at -2 and -1. So I put them on the number line. I'm plugging them into the first derivative. So I'm plugging in things that are in each interval. So if I plug in -3 into my first derivative, so I'm plugging in right here. I have 12 times a negative number times a negative number. I'm going to get a positive number. If I plug in -1.5, I get 12, I get a positive, I get a negative, so I get a negative. And then if I plug in 0, I get a positive, 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 so I get that. So it means my function is going up, down, and up. Always think, does it make sense? Yep. Yes, it makes sense because your original was 4x cubed. All right, it's going to be an x cubed one. All right, the second derivative. My second derivative is going to be f double prime is equal to 24x plus 36. I've set it equal to 0. I could pull out a common factor, but it's much easier just to subtract 36, right? And divide by 24. Did you already pull out a common factor? So you get -3/2. Okay, so this is now the second derivative that we're plugging into. So I put -3/2 here.
This is concave.
What do you think it's going to be? Oh, yes, it does concavity, yes. I thought you were saying, will it be concave up first and then concave down? What do you think it's going to be? Based on what shape it is, which is an x cubed, what do you think it's going to be? Down and then up. It better be down and then up, right? It better be. If you didn't do it, then you're wrong, right? So you're going to plug in here. So if I plug in like -5, I don't know, something really big, I get a negative. If I plug in a positive number, I get positive. So it's down and up. It's exactly like you thought it was going to do.
I knew it.
Right? Some things are not hard. It's obviously the more complicated ones where we really need to do the little charts. All right, now remember the charts. The AP test does not grade those charts. So if you were drawing anything about f, you would need to write out something like f prime is greater than 0 on this interval and this interval, and f prime is less than 0 on this interval and this interval. You would do all of that. All right, so what do I know so far? I know that there is a maximum at -2. There's a minimum at -1. Point of inflection at -3/2. So I need to find those values. So this is where I'm kind of nice to you. I'll let you use your calculator as if it's a scientific calculator. So I will let you find f of -2, f of -1, and f of -3/2. If I have to find a lot of values ever, I always put in, I like use the table. What did you guys get for -2?
I got 0.
So 0, and then -1, you get -2. And -1.5, you get -1. All right, so on the next page, of course, I didn't put it all on one page. I have a sketch. So yours is all on one page, right? So we have our sketch. And we had -2, comma 0. And that was a max, right? So I'm going to do like a little bump there, so I remember that's max. And then I have -1, comma -2. And that was a min. And then between them, right, at -1.5, comma -1, I have a point of inflection. So on my graph, I'm just going to do like a little star or something, so I remember that's a point of inflection. Okay. Horizontal asymptote, none. Any intercepts? I found one of the x-intercepts, right? I had that. Will I have more? Yeah. So going back to my original, if I want to find an x-intercept, so I have 4x, what was that? 4x cubed, read it to me. 4x cubed plus. Yeah, so you could try to split the middle. This one doesn't work. Like, you can't do factor by grouping. But I do know one of the zeros. So that's kind of nice. If you want to know one of the zeros, I know that -2 is a 0. Synthetic division. So I get -8, 10, -20, 4. The AP test never does this to you guys. No worries. So I'm left with 4x squared plus 10x plus 4, right, times x plus 2, basically. That's what my original function is. I've factored it. How do I find any more? You could do synthetic division some more. Or it's an x squared. You can't actually factor, I don't believe. If you pull out a 4, oh, not a 4, a 2, I guess. I can't do 4. Then I get 2x squared plus 5x plus 2. Does it factor? It might actually. 2x, x, 2, 1. Right, it does factor. Am I right? Outer is 4, inner is 1. I'm not, because they're not very confident. It's making me comparing lots of like, does it? Yeah, it does. So your x-intercepts are -2, which we already had on the graph, -1/2, and -2 again. Right, remember in Algebra 2 we called that multiplicity. Oh, Hannah, I'm so proud. Yes, it's multiplicity. That's why it kind of bumps back down. Like it hits it and then it goes back down. Okay, so it's also going to go through a -1/2, so right here. All right, and then the y-intercept is the easy one. Y-intercept, you plug in 0 for x. So the y-intercept is 8. So it's 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Everything you never want to know about that graph. Now, if you were nice to your calculus teacher, you would label. You would say max and write it, min and label. Yeah.
Why would we be nice?
Why would you be nice to me, right? You want me in a good mood as I'm grading your homework. All right. So we've now graphed a graph. Everything we'd ever want to know. All right, same thing here. So I have x squared minus 3 over x cubed. Domain, what's not in the domain? What can I not have? 0. So it's -infinity to 0, union 0 to infinity. Vertical asymptote is at x equals 0. First derivative. Uh-oh.
Low D high.
You would think low D high, but you can make it easier. No, you can't do L'Hopital hospitals. You can't do L'Hopital because it's not like a limit. You're not finding the limit of something.
Oh, you can divide something where you like.
Oh, you're right over there, Nia.
I can't
Divide what?
divide the x cubed into the thing.
Exactly. Why are you making it hard on yourself, people? X squared divided by x cubed minus 3 over x cubed gives you 1 over x minus 3 over x cubed. In other words, x to the -1 minus, do I need to pull that down? Of course. 3x to the -3. So you can't see this. All my beautiful writing here.
Oh my god.
Wow.
little things in life. Being able to track writing. All right, there we go. Okay, make it easy on yourself. We talked about this like in chapter 2. We were like, why are you doing quotient rule when you don't need to do quotient rule? So don't make it really hard. So first derivative, f prime is equal to negative 1 x to the negative 2 plus 9 x to the negative 4. That was the test you guys all ran out of time, remember? Yeah. All right, but I really need to think of this as negative 1 over x squared plus 9 over x to the 4th because I need to find critical values. So I should really get common denominators. So I'm going to multiply by x squared over x squared. So I get 9 minus x squared all over x to the 4th. Did you guys see that? How I did that? Negative x squared plus 9 is 9 minus x squared.
Oh.
Okay, so I'm finding when it's equal to 0. I'm also finding where it's undefined. So it's definitely undefined at x equals 0. So that's a critical value. And then this factors into 3 minus x and 3 plus x. So I have x equals 3 and x equals negative 3. So I have 3 critical values. So on my number line, I'm going to put 0, but I'm going to do like a little dotted line so I remember that that is an asymptote. There's not going to be like a max or a min there. So I'm going to put in negative 3 and 3 on there. And I'm going to try on the left, like I'm going to try in each interval. So if I plug in negative 4, I get 3 minus a negative 4, so that's positive. 3 plus a negative 4 is negative. And then the bottom is always positive. We're lucky. Whew. So positive times negative is a negative. If I try like negative 1, I get a positive, so plus. If I try 1, I get a positive times a positive, so plus. And if I try 4, I get a negative times a positive, so negative. So it's going down, up, down. So there's a min at negative 3, and there's a max at 3. Okay, second derivative. We're going off of this one. It's not that bad, right? So the second derivative is f double prime is equal to positive 2 x to the negative 3 minus 36 x to the negative 5. So just like before, I need to see what the numerator and denominator is in that expression. So I have 2 over x cubed minus 36 over x to the 5th. So I need to get common denominators. So I'm going to multiply by x squared over x squared. So I'm going to have 2x squared minus 36 all over x to the 5th. So for the second derivative, I have 0. What else do I have? I would have x squared equals, like I would add the 36 and divide by 2, so I'd have 18. So how do you? Square root of 18, which is 3 root 2. It's okay, I was pretending I didn't hear. Yes, she said 9, it's alright. It happens to the best of us. Okay, so we need to check in each location. So negative 3 root 2, I don't know, like what is that? What's it around? Negative 1.4 times 3, negative 4.2, somewhere around there. So do like negative 5. So if I try negative 5, on the top I get 2 times 25 is 50 minus, so I get positive over a negative, so negative. And then if I try something smaller than that, like negative 1, I get a negative on top over a negative, so positive. If I try 1, I get negative on top over positive, so negative. And then if I try bigger, I get positive over positive, so positive. So it's down, up, and 0 is still an asymptote. That's why it's a critical value there. not a critical value. We call them points of interest for the second derivative, something like that. So critical values for first derivative, points of interest for second derivative. Think of points of inflection. All right, so we need to graph it out. So let's find some different values. So we need to find lots of values. F of -3, f of 0, f of 3. Those are all going to be, well, f of 0 is nothing, right? That doesn't work. That's an asymptote. And then we need to do f of 3 root 2 and f of -3 root 2. All right, so let's try it.
Instead of f of 2 root 2 would be f prime.
No, you're still trying in the original. You want to know what the inflection point is, yeah. So what do we get for 3? Negative. Okay, -0.2 repeating. Is that what she got? Okay. Or -2/9. Yeah, that's 2/9. And the same thing for -3. Did you get positive?
Sorry, I meant for -3 it's negative, for 3 it's
Okay, so positive for this one and -0.2 repeating for this one. So that's 2/9 if you want to write it as a fraction. What about 3 root 2? Did anybody do that one?
Yeah. About 1.19.
0.196 for both of them?
The negative one I got is negative.
Negative is negative. Okay. All right, so it's symmetric. I don't know if I have enough room. Oh, man. I got to go to the next page. Got to remember all these numbers. So my sketch. So the -3 is a min, so it's -3 comma -0.2. So that's a min. And then I have basically the opposite, 3 comma positive 0.29. That's a max. And then I had 3 root 2, which is, what did I say that was, like 4.2? 0.96? Is it 4.2? 3, what's 3 root 2 though?
Yeah, 4.26.
Okay, so 0.42 something. Okay, and then it's 0.196. So it's down here. And then same thing here. I know. It's going to be really weird. Oh, that one's below the axis. Sorry. Okay, but what's really going to help you with this is the horizontal asymptote. So going back to your original, you have x squared minus 3 over x cubed. You should all know how to find the horizontal asymptote. What is it? 0x cubed over 1x cubed. It's a shortcut method. We have done this since the summer review packet. Horizontal asymptotes, this is the shortcut method, where you look for your largest degree. Your largest degree is x cubed. You don't have an x cubed on the top, so you put in 0x cubed. So you have 0x cubed over 1x cubed, which is 0 over 1, which is 0. So you have y equals 0 as the horizontal asymptote. So you're going to have a little dotted line here. So mean. Intercepts. If you plug in x equals 0, you get undefined. So there's no y-intercept. Is there an x-intercept? If you set the whole thing equal to 0.
You did.
So you have x squared minus 3 over x cubed.
Well,
Is there a way to get it equal to 0? Plus, yeah, you're right. Yeah, x equals plus or minus, sorry, I wasn't paying any attention. X equals plus or minus root 3, right? Does that make sense?
yeah.
Okay, so that's like 1.7. So it can cross a horizontal asymptote in the middle. It can't on the ends. Because a horizontal asymptote, all it is, then, Lauren, pay attention. All it is it's what's happening on the end, right? Limit as x goes to infinity, limit as x goes to negative infinity. So it can cross right here and right here. It can cross in the middle. Okay? Weird, huh? So what's going on with this graph? It is a very ugly graph. All right, it's got a maximum there. It's going along the horizontal. It's got a minimum here. And then it goes along the horizontal. It crosses at these points.
Oh my gosh, we did this because there's no, because there's also a vertical asymptote.
Where's the vertical asymptote?
Oh yeah.
I forgot to draw on the vertical, didn't I? Where's the vertical? X equals 0.
This is, so you can,
So where's it going to go?
it's just gonna go through those points.
And it goes up.
Wait, but can it not do that because if it
Yeah.
passed it?
It can cross the horizontal, guys. It just can't cross on the ends of the horizontal asymptote. Because what a horizontal asymptote is the limit as x goes to infinity.
Isn't there a horizontal asymptote that's 0?
Now, does it follow? Look at our different things. Does it follow our this here and this here? Let's look. So is it decreasing, increasing, increasing, decreasing? So down, up, up, down. Does it do that?
Yeah.
Down, up, up, down. Does it do concavity? Whoops. Concavity, down, up, for concavity, down, up, up. Point of inflection's right in here somewhere.
Why can it cross the horizontal asymptote?
Guys, even in algebra 2, you could cross the horizontal asymptote. Remember we would have these graphs that would look like this? Like, we would have some that went like that, and then we'd have, like, here and here. It can cross in the middle.
So it's just that it's just limit that like
You can't cross a vertical. You can cross a horizontal.
but does it only limit that like as it goes to negative causes to